Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2023 Maths Methods Exam 2 for the Northern Hemisphere Extended Response. I've had a lot of students in the comments down below tell me to go through this paper. And yeah, so these are my suggested solutions to these answers. Then, I can make one or two mistakes, but that's not a problem. And yeah, so let's do this. And before I start, guys, if you want private tutoring, I do tutor online from my Discord. I have a Discord server and it's a Discord school, and I have a lot of students. I think close to 20. Places unlimited, and you can pretty much email me down below if you want a spot down there. You get thousands of questions for maths methods, specialists, physics and chemistry, where I'll go through go through questions with you. And we also have a Q&A section there where you can post anytime questions, and I will help you solve them. So yeah, let's go through this exam. Quite tired. I just came back from uni, and yeah, let's go through this paper. So question 1. Let G be all reals, blah, 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 G of X. Okay, so it's a parabola. Express the rule of G in the form of G of X this, where A and B are all C and element of all reals. Very nice and easy. So what I'm going to do first is I'm going to define the function. So for G of X, I'm going to define it as x plus 2 squared minus 1. Okay? And I want to expand G of X. Aha! That's your answer. So, G of X is equal to x squared plus 4x plus 3. Nice. Next one. The function G can also be written in the form of G of X, and this, where P and Q are elements of all integers, give the values of P and Q. So nice. So what I'm going to write is I'm going to go on factor your answer. Aha! There we go. So P can be -1 or and Q can be -3, or it could be the opposite. You can write P is -3 and Q is -1. I think you just need 1, to be honest, for this question, but yeah, any of these two should get you that mark. All right, let me just get a nice color. Find a value of k for which the graph of G of X plus k passes through the origin. Okay, let's draw this function, G of X. So if I'm drawing that, let's just draw it. Okay, like this. So this is your X, this is your Y. And I'm going to say, let's say, this is right over here. And it's going to go like this. And it's going to go like this, something like that. And so what's the y-intercept? Well, what's G of 0? It is 3. So this point over here is 0, 3. Perfect. And this point over here is -2, -1. Okay, so find the value of k for which the graph of G of X plus k passes through the origin. Remember, that k is a translation up or down. So it's telling us what translation will give us, will make this whole function pass through the origin. Now really look at this question. Well, our y-intercept's at, 0 and 3. So if we take this and we put it down, can you see how we can translate it? It goes translating up or down. And what we want to do is, what translation would give us, what k value would give us, where we touch the origin? Okay. Aha. We touch the origin when we translate it -3 units down. Can you see how it's in our y-intercept? And if we go down 3 units, perfect. It passes through the origin. So our k value for this one, we can say, we can say our k value is -3. It means -3 units downwards. Perfect. I hope that's right. Yeah, I hope that's right. Next one, D. Using algebra, find the values of D such that the graph of y equals G of X minus D will pass through the origin. So we want it to pass through the origin. Okay, to make that happen, okay, so we know G of X is this. So G of X is x plus 2. So x plus 2 squared minus 1. Is that right? Yep. And we want to write G X minus D. So x minus D plus 2 squared minus 1. Using algebra, find the values of these such that the graph of this will pass through the origin. If we wanted to pass through the origin, which is 0 and 0, we want this to equal to 0. So if we solve this, to find the y, like the x-intercepts where they will equal. So if we, yeah, because remember, we want this y here to equal 0. So if we equalate this whole function, minus 1 equals 0. So we can say x minus d plus 2 squared equals 1. X minus d plus 2 plus a negative 1. X d minus 2 plus or negative 1. So x can be d minus 1. Is that, yeah, so 1 minus 2, negative 1. Or x d negative 3. And remember, we want also our x-intercept, our x value to be 0. So taking these two over here, the first one, if we let x equal 0, d minus 1, d is therefore 1. For the other one, 0, d minus 3. Therefore, your d should equal 3. So these are your two values of d that will make it pass through the origin. So d must equal 1 and d 3. These over here should give you that. Those are your answers. Hope that's right. Describe the transformation of the graph of g of x to the graph of this. Okay, very nice. So this, you can write it in two ways. You can write it as a dilation. I think I spelled that right. Dilation by a factor of 1/3 parallel to the x-axis. Yep, so dilation by a factor of 1/3 to the parallel to the x-axis. You can also write it as dilation by a factor of 1/3 from the y-axis. Both of these should get you the mark, but yeah. So one of these, you can write one of them, just yeah. So if you write one of these, you should get the mark. Let h of x be this, where m and n are real numbers. Find a value of m such that the graph of the sum of g of x has a turning point. So turning point on the y-axis. So if we want a turning point at the y, so imagine it was a parabola. So let's say we had a parabola, and this, we want it to be the turning point on the y-axis. So it means our x should always equal to 0, and our y changes. But yeah, so x must equal to 0. I'm just going to write that here. X should be 0. I'm going to rub that all off. Okay. Alright, so what am I going to do is, okay, I know that it's the sum of them. So your new function, let's say y, is g of x, which was in the old one. I will just, so x squared plus 4x plus 3. So I can say x squared plus 4x plus 3. And plus h of x, which is plus mx plus n. So I'm going to put some terms together. So this, you can say 4 plus m, x plus 3 plus n, this. And what we want, okay. Now you should know the formula, like for the turning point, to give you the x value of the turning point, x equals negative b over 2a. And we know that we want our x to be equal to 0 for us to get a turning point on the y-axis. So if we let that equal to 0, and this is our b value, you should know that this here is our b value and this is our a value, which is just 1, a constant 1. So putting that all together, so negative, what's our b value? So 4 plus m all over 2. And so we can say that's 4, negative 4 minus m. Your m should equal to negative 4. So find the value. Yeah, so value, not value. So yeah, the value is m equals negative 4. Hope that's right and haven't made a mistake. Yeah, I hope that's right. Okay, yep, just here. Nice and easy. Find n in terms of m, such that the graph of the sum of g of x plus h of x has a turning point on the y-axis. So if we wanted a y-axis one, let's say we had this, and we wanted it on the x-axis, the turning point, the y must always equal 0. So I'm going to do this on calculator. So now, just to make my life easier, yeah. So what I'm going to do is, if you go on your CAS, and first let's define h of x, because we actually haven't defined it. So h of x is m times x plus n. Okay. And what we want is g of x plus h of x. That's the actual function that we're dealing with. Plus h of x. And we get this. And what we want is, we want it in terms of turning point form. So if we go on menu and go on algebra, complete the square of this whole function, comma in terms of x, and we get this beautiful, nice equation here. We could have used this a faster way, like we could have done this straight away and, you know, for the last question, but yeah, it's all right. And this is what we want to have. This is your y, like the turning point into terms of y. And we remember we want that to be y equals 0, because that's where our turning point on the x-axis will be. So if I take this and write it down, like the whole, because it's 2 marks. So if I write this whole thing in turn up for, so x plus m plus 4 over 2 squared minus m squared over 4 minus 2m plus n minus 1. And we want this part to equal 0. So we can say that n this and we want to solve for n. Doing our calculator, so if I go and solve this whole thing here, just this part, equals 0 for the value of n, we get this nice. Okay, so that's your answer. So we can write n is equal to m squared plus 8m plus 4 all over 4. Is that right? So find in terms of m such that the graph of the function has a turning point on the, yeah. So yeah, should be right. And it says find 2 pairs of values for x. So find 2 pairs of values for m and n such that the graph find the 2 pairs of values such that the graph of the product function of g of x and h of x has exactly 2 intercepts, 2 x-intercepts. Wait, find 2 pairs of values for m and n such that the graph of the product of this has exactly 2 x-intercepts. Okay. So we can say y, because it's g of x times h of x. I'm going to use the... okay. I'm going to use the form of g of x in the form, if I go on my calculator, yeah, so I'm going to use the form this for g of x, so it's x plus 1, x plus 3, and h of x as, what was it, mx plus n? Okay, find 2 pairs of values of m such as the graph of the product of this has exactly 2 x-intercepts. So we want that to equal 0 to solve. Now, absolutely, there's an absolute answer here that we already have 2 intercepts. So what we want this to be is we want this to not exist, or we can create a repeating factor. For example, because it is not a now quadratic, it's actually a cubic root. It's a cubic actually, not cubic. Yeah, so it's a cubic. So we already have here 2 solutions. So, and we cannot let like this equals 0, because if this actually here equals 0, the whole function would not exist, because then this gets multiplied by 0. So the only way we can actually do this is, let's say we solve this part over here. So for x, so mx plus n equals 0, mx equals negative n, x equals negative n over m. And okay, so what else can we do here? Okay, what we want is to make sure that we want our x, because like, you know, this here, this is x equals negative 1 and x equals negative 3 for these. We want them to be the same for this value, because then that creates a repeated root. And that then still has 2 solutions, at least 2 x-intercepts. So what we can do is let's try this first one here. So if I let that equal there, so it'll be -1, negative n over m, which is just 1 equals n over m. What values of m and n will give us 1? Well, n equals 1 and m equals n. So n equals 1 and m equals 1 will give us 1. So we can write that. That's one pair. So I hope that's right. So we can say one pair is n equals 1 and m equals 1. Yep. Let's try to do it for the next part or next one. So let's say for the next one is -3. For this one is negative n over m. So 3 is n over m. So we can say n is equal to 3 and m is equal to 1. Perfect. So I think this over here, yeah, should give us those solutions. So these are 2 pairs. I mean, there probably is there's more pairs, but yeah, it just tells us find 2 pairs. So I think these are the most easiest pairs you can take. So I'm just going to, there you go. Nice and easy. Hope that's right. Find the coordinates of the turning point of the graph this. Give your answer in the form of this. Okay, so I'm going to go on my CAS actually. And just write it. What's g of h of x? Aha, so it's this, okay, this ugly function here. So I'm going to write it down. So g h of x is m squared x squared plus 2m, m plus 2, x plus n squared plus 4n plus 3. Now we can use that formula, negative b, so x equals negative b over 2a to get the x coordinate of the turning point. So that'll be negative 2m, m plus 2 all over 2m squared. And, simplifying down, I'm just going to use my calculator. It makes my life easier. What's negative of negative 2m, m plus 2, 2m squared. That gives you n plus 2. So is that right? So m plus 2 over m. Yeah. M plus 2 n. And if I sub that into the function, so if I go in here and sub it into this function. Oh, okay. That's what x equals. What? Is that right? Have I made a mistake here? Okay, I'm going to make my life easier. I'm just going to go in, algebra, complete the square of this function over here, comma x. Okay, it's just done it for me a quicker way. So I'm going to just, I should have got x as negative there. Why did I not, what did I do here wrong? So I wrote negative b, which is negative 2m, m plus 2, over 2m, yes, s squared. Let me just do this on hand by hand, quick. Why did I get that? So 2m, m plus 2, 2m squared, cancel out, m plus 2 of m. Yeah, that's x. Why did I do something wrong here? Did I write it wrong in my... So mx squared plus 2m n plus 2. I have no idea what I did wrong here, but yeah, I'm just going to rub this off and just say x, okay, this g of h of x, can we just written as m squared x plus n plus 2 over m squared minus 1. So your actual coordinates of the turning point are negative n minus 2 over m and negative 1. Is that right? So negative 1 there. Yeah, and the negative of, so perfect, negative 2 should be that. Hope that's right. I'm just going to double check it. I'm going to double check it. How? So if I take this over here, and let's say, give any values, let's say n is some, actually, it's too much. Yeah, I think it should be right. I don't think I should be double checking that. It should be enough. Yeah. Just one double, so negative n, so it'll be n plus 2 over m. Yeah, it looks right. Perfect. Okay. Done. Perfect. Hope that's right. Next one. Question 2. The amount of caffeine present in Kim's body after they drink an espresso can be modeled mathematically. Students suggest that the amount of caffeine in C milligrams of Kim's body 2 hours after consuming espresso coffee can be modeled by this. How much caffeine will be present in Kim's body 2 hours? So 2 hours after they consume an espresso. Give your answer in milligrams to 1 decimal place. So yeah, I'm just going to go on my calculator and just define a new function. So let's write, let's define C on T. So it's 65 times E negative T over 8. Perfect. So, and we want to find how much caffeine. So we want C of 2. Perfect. Control Enter to 1 decimal place. So we want C of 2. So it'll be 50.6 milligrams. Perfect. Next question. How long will it take for the amount of caffeine in Kim's body to reach 10 milligrams after they drink an espresso? Okay, so nice and easy. So we can just say, what's C on T when it equals 10? And we can solve that. So solve C on T equals 10, comma T. And we want, so T is 14.97442. And we want to give your answer in hours, yes, and minutes. So in terms of hours, T is 14 hours. And to find the minutes, the decimal place over here, which is what? 0.97442, we want to multiply by 60. And so that should give us our minutes. So if I say 0. This over here, times 60, gives us 58. So it'll be 58 to the nearest minute. Yeah, 58 minutes. Nice. At what rate is the amount of caffeine in Kim's body decaying? So, okay. 4 hours after they drink it. Give your answer in this. At what rate? So we want to find, okay, what's C dash on T? Just do that. So shift this. So what's C on T? Okay, so it's this. So it'll be negative 65 E negative 2 on 8 all over 8. And we want to find when it's 4 hours. So writing that, so taking this, given that T is equal to 4, we get negative 4. Oh, no, actually, we want it in this form. So we don't want to write in decimals. So it's equal to negative 65 E negative half all over 8. Now this form can, this form over here, if we simplify it, it's pretty much 8 root E. And because it says it's already decaying, we don't need that negative. So if we want it in that form, we just get rid of that negative here. Yeah, so pretty much, yeah, that's so give your answer in milligrams per hour in terms of this, where A and B are positive integers. Perfect. So they are positive integers, and yeah, milligrams per hour. Perfect. Is that right? Milligrams per hour. Yeah, looks good. Let's go. Next question. Kim consumes another espresso coffee 4 hours after consuming the first. The student then suggests that the more appropriate model for the absorption of coffee in milligrams in Kim's body 2 hours after they consume the first espresso is this. So it's a hybrid function. And so when T is greater or equal to 4, is the function Ct strictly increasing, decreasing, or in neither? So we want to find where T is greater than 4. Okay. First, I'm just going to make my life easy and just like control N all of this and define this new function. So C on T as this hybrid function, which is, if I go in here, so 65 times negative 2 on 8, 65 times E negative 2 over 8 times 1 minus E and 1 minus root e. Okay, have I write it right? Yep, so 64 times e negative 2. This times 1 minus e, 1 minus root e. Okay, and the domains is from 0. So t is 4. And t must be greater or equal to 4 for this one. Okay, now we have this. So when t is... Okay, so I'm just going to graph this. So if I go in here, and what's c on... I want it in terms of x to make my life easier. And I'm going to zoom fit. Okay, here it is. So, and we want when t is greater, so we just want this graph over here. We can see that the graph is strictly decreasing. And yeah, it's strictly decreasing to 0. So pretty much, yeah. So C2 when t greater or equal to 4 is strictly decreasing. Okay, C2 when t is strictly decreasing. Show that that function C2 is not continuous for t is greater than 0. And it makes sense. Why? I mean, let's look at here. It's a break. They're not actually continuous. So the way I would suggest that you prove this is to say, is this function over here, when it's equal to 4, equal to this function over here when it's equal to 4? Let's try that out. So we can say, is 65e negative 2 on 8 so that's continuous. Yeah, is this function equal to 65 1 minus e 1 minus... Okay, wait, let me just take this time. Okay. Yeah, so we want this here. So 65 et when t is equal to 4. So 65 t is 4. This becomes... So if I go on my calculator, take this over here. When t is equal to 4, it is 39. So when this... So 65 negative et when t is equal to 4, it equals 39.4. And when 65 e negative 2 on 8 of 1 minus e, 1 minus root e, is... So is equal to what? It's actually equal to taking that here and saying that when t equals is 4, it's equal to 104.4. And they are not equal. And I just want to take this here, make it easier for students to understand. Bring this over here, take this here. It's equal to that when this is that. Okay. And I also want to copy that. Here. So 65, 39 is... Yeah, so what can we see? That when t equals 4, they are not continuous at that point. It means, look at this. When this is pretty much, yeah, like this value is totally different to this value. And yeah, so they are not continuous. I think that's the way you would prove it. I'm not kind of sure in this kind of question, but yeah, you can even see from this graph that, yeah, it's not continuous at the t equals 4. So hope that gives you the mark. Using C2, find the maximum amount of active caffeine in Kim's body and the time in which the level was reached. Give the maximum amount of caffeine in milligrams to correct 1 decimal place. Okay, if I just look at the graph, I mean, the most maximum value is when the second equation, when t is greater or equal to 4, is when it's at its, when t is equal to 4. This is where it's the most maximum. I hope that's right, yeah. So, what can we say? Well, we can say it occurs, so find the maximum amount of caffeine and the time which occurs. So we can say that it's only 2 marks, so it should be all right. So at t equals 4, and we can say that 65 1 minus e 1 minus root e negative 4 on 8 should equal to what? It would equal, correct to 1 decimal place, which was this one, yeah, when t equals 4, which was 104.4 to 1 decimal place Yeah, hope that's right. Have I done a mistake here? Yeah, milligrams. Perfect. So using C to find the maximum amount of caffeine in Kim's body and the time in which level was reached, give the maximum amount of caffeine in milligrams correct to 1 decimal place. Yeah, so that should give you the mark. So we know it occurs at t equals 4, and we've given also this here. We've given this. Perfect. Find the derivation of C on T, giving your answer as a hybrid function that includes the relevant domains. So, okay, C2 this is equal to like a hybrid function. So, one of the ways that I would do this is just go on pretty much menu, calculate, calculus, derivative, well, in terms of T, of the function C on T. And blah, blah, blah. Here is your actual hybrid function, and it does give you the relevant domains. So let's write that. 65 e negative t on 8 all over 8 where 0 less t 4, so that, and also, okay, that's very big, so I think I'm just going to move this a little bit here, just rub this off, something like that. Let's make it bigger so it's easier to deal with. So if I bring this over here, okay, E1 this, E negative 2 on 8, all over 8 this, where t is greater than 4. Yeah, so that is your hybrid function. Find the derivative. Is the appropriate rule for domains? Yeah, it looks right. Hope that is right. Perfect. Use the derivative C on T to find the times during which the amount of caffeine, so the amount of caffeine, active caffeine is decreasing by at least 8 milligrams per hour. So here is a rate, yeah, so we have to use the derivative, express your answer in the interval notation, correct to decimal place. So what we want to find is when C2 dash of t is less or equal to 8. Yeah. No, negative 8. Negative 8, because they tell us that it's, well, where is it? At least by 8 milligrams per hour. Find the times during which the amount of caffeine is decreasing. Yeah, decreasing. So we want to make sure that's negative 8. And let's solve that. We can use our calculator. So we can solve this here to be less or equal to negative 8 comma t, and control enter. It gives us these nice, yeah, that should be your answer. And we want it in terms of interval notation, so we can say that t is an element from 0 to, in 1 decimal place, so 0.1 close bracket union 4 7.9 close bracket. Yeah, that's your answer. Hope that's right. Okay. Question 3. Consider the graph of this, where a is a real number with a turning point A and C, as shown below. Find, using calculus, an expression for the shaded area in terms of A, bounded by the function g and the horizontal. Okay, so we just want that area, so that's not bad. So we can say that area, wait, using calculus, find expression. Wait, find using calculus an expression. We just want an expression for the shaded area. Yeah, just like a equals what? So we can just say a is equal to the integral from negative a to 0 of f of x. Well, f of x in this term is x to the power 3. So x to the power 3. Oops. Minus ax. Yep, dx. We want to put a minus integral from 0 root a of x cubed minus ax dx. So here, we've just written an expression that would give us this area for the shaded area in terms of a. Yep, it is in terms of a. Bounded, wait. I want to make sure, because I'm very confused with this one. Do they want me to like integrate it? So find using calculus an expression for the shaded area. I think, yeah. So this over here, I think that's 1 mark. And if I put that over here, So simplifying, I'm just going to use my calculator. So a should equal to what? So I'm just going to control N this. And I'm just going to define the function f of x, which is f of x to the power of 3 minus a times x. Okay, and we're just going to want from, so we want from negative root a from 0 of f of x dx minus 0 to root a f of x dx. So it gives us a squared over 2. So a squared over 2. So yeah, I think that's that. Hope that's right. The turning points of the graph of f are also vertices of the rectangle ABCD as shown below. The line segment AC is the diagonal of the rectangle. Okay. Calculate the area of the rectangle ABCD when a equals 4. Okay. Not too bad. Well, I know for a fact, well, the distance here to here is this minus this, which is pretty much, you can write it as, yeah, so area is root a on 3 minus, which is just, again, becomes plus because that's a minus here, so it'll be, well, it's not this, actually. It's root a on 3 plus root a on 3 times this minus 2 a on 3 over 2 minus 2 a on 3. Okay. What am I doing? What am I doing here? Okay. It's supposed to be this minus this. Because, yeah, so it'll be just... I'll make it... Yeah, so it'll be 2 a on 3, 3 on 2, plus, because we cancel those minuses out, so it'll be 2 on 3, 3 on 2, and the area should equal some value. And I'm going to do that on my calculator, so we can say it will actually just be 2 square root. This one will be just 2 square root of a on 3 times 4 times a over 3 to the power of 3 over 2. Yeah, if that's right, and enter that, and we get this here. So it'll be 8 a squared on 9, and we know that a should equal to 4, so a equals, so if I take this and say that a should equal to 4, and we get 1 to 8, so 1 to 8 over 9 units squared. So yeah, hope that's right. 2 marks. It took so long. I don't know what's... Yeah, I don't know why it took that long. Explain why the value of a must be greater than 0 for the area of the rectangle to be positive. So, okay, we have this over here that can help us. Well, remember, like, if we draw a parabola, let's say, for example, we draw a nice parabola here. And let's say this was area, and this is our value of a. And it pretty much looks like this. It's a parabola that passes through 0, and it goes like this. And what can we see? Well, our a values can be anything. It can be from negative infinity, negative infinity to infinity, pretty much. But you must remember that we only take the positive. We only take this positive part here, and we ignore this negative part, the values of the negative a's, because we only want. And why is that? Well, you remember if you look over here, this value here, or let's actually take this value. The square root of a on 3 must be greater than 0. I mean, a must be greater than 0, because remember, if there's a negative number in a square root, what happens? It doesn't exist. It just, yeah. So we cannot have a negative in a square root. So what do we actually know? Well, we know that a must be greater or equal to 0 because of that square root. So we can say, like, yeah, so yeah, a must be greater or equal to 0. But also, we want to make sure that it's not equal to 0 due to the fact if it was equal to 0, then this length does not exist. Imagine that, yeah, if you put 0 over there, it pretty much, yeah, it will become the point here, 0, which is wrong. So, yeah, that's why it's a is greater than 0. It can only be a greater than 0. So to write that, I'm just going to write this nicely. So I'm going to say, yeah, like drawing this, we can see that a goes from negative infinity to infinity due to a must be greater or equal to 0 from square root a on 3. Yeah, so yeah, that. From a on 3. But also a cannot equal 0 because x will equal 0, x equals 0 or something. Yeah, x equals 0. And yeah, so I don't know how I would write this pretty much, but yeah, like I hope you understand what I mean. Like that's how you would like explain why the value of a must be greater than 0 for the area. Well, yeah, because normally a can be anything, but due to it's a square root and it means a is greater or equal to 0, but also it cannot equal to 0, so a must also, so a must only be greater than 0. I hope that's right. So the a is greater or equal to 0. X will become, we want to say x will become, because wait, due to the from here, but also will become therefore this. I hope that's right. Show that the area of a rectangle ABC can be written in the form of this. Well, we already have it here, so that's good. So we can say area is 8a squared over 9, which is area, take the 8, a over 3 squared, and we can take that area 8 I on 3 squared. Yeah, we've shown that. Nice. Find in terms of an expression for the length AC. Okay, so the length AC, so we want to find that length. So A is here and C is this point over here, and we know the 2 points are just, okay, yeah, so we already know the coordinates, so that makes our life easier. So what I'm going to do is, yeah, I'm going to just say it's pretty much the square root of this minus this, so negative 2 a on 3, oops, a on 3, a on 3 over 2, minus the same thing, but it's, yeah, it's in the positive, so 2 a on 3, 3 on 2, all squared, plus same thing as the other one, root a on 3 minus, it'll become plus root a on 3 all squared. Yeah, okay, so doing that, your AC in terms of A would be this. Let's do it on our calculator. So, okay, so it will be, what's the, okay, these will add up, so it'll be negative 4 here, so it'll be negative 4 a on 3, 3 on 2, okay, and we square it, is that right? Yep. Plus 2 square root a on 3 all squared. I hope that's right. Enter, and we get this over here. Yeah, so let's write that. So we can say 2 square root 3a 4a squared plus 9 all over 9. Yep, so in terms of a. Hope that's right. Find the values of x for the points on the graph of f in terms of a where the tangent to the graph of f is perpendicular to AC. So, find the values of x of the points on the graph of f in terms of a where the tangent of graph of AC. Okay, perpendicular to AC. What I'm going to do here is I'm going to make my life easier and say, what's the gradient of AC? Like, yeah. What is the gradient of AC? The line AC. So, if I say AC here, well, I know AC is like these 2 points, and we can find the gradient of them. And that's easy to find the gradient. It's just, so let's say, let me write it nice. So let's say gradient. So gradient of AC is equal to, okay, negative, let's say, so it's this, so if I can just, okay, it will be negative 2, it'll just be, yeah, negative 4 actually, negative 4, make my life easier, a on 3, 3 on 2, and then, so because it's that, minus that, and this, minus that, so it'll be just 2 root a on 3, yeah, so m, or your gradient of AC is what? So if I go on my calculator and say this point over here, put over here, yeah? And this point over here, this point over here, put over here, enter. It will give us this, negative 2a on 3. But we want, if we can just make our life easier, so we want the perpendicular, so a on c, it'll be negative 1 over negative 2a on 3. So m perpendicular is what? So if I say, what's negative 1? Or, let me just do my calculator. Yeah, so negative 1 of, answer. It's 3 over 2a. So we have that, so that's good. And we want to find the derivative of f dash of x. Yeah, we want to find the derivative of f dash of x. So, that's easy. So if we go in derivative of f dash of x, that'll give us 3x squared minus a. And if we equate them both together, yeah, so if we equate them both together, it'll be 3x squared minus a equals 3 over 2a. And we want to solve for x, because we want the x values. Okay, so we want to solve this equaling this, comma x. And we get these two over here. Yeah. In terms of a. In terms of a, yeah. And it says find the values. So yeah, we just need this. Let's write those. So different color. So x is equal to the square root. I hope these are right. 6 2a squared plus 3 all over 6 root a. And your other value is negative. Yeah, so it'll be negative 6 2a squared plus 3 all over 6 root a. Yeah, so these are your two. Yeah, I hope these are right too. Oh, these questions are draining. And there's no solutions to these questions. They haven't like publicized them. VCAR hasn't publicized them. So yeah, these are just suggested solutions. I hope these are all right. Okay, question 4. How long? And then there's question 5, and yeah. Okay, let's get this quickly done. So question 4 says, A bakery makes thousands of cupcakes during a morning shift. On average, 70% of the cupcakes are vanilla flavored. A large sample of 100 cupcakes was inspected by the manager to calculate the proportion of P that were vanilla flavored during the morning shift. Let P be the random variable representing the sample proportion of vanilla flavored cupcakes. State the mean of P. Okay, very nice. So we know that the expected value of P, proportion of P, is just P. And our P value in this case, so let me just write A on P, is 0.7. It's this 70% here. Perfect. That was nice and easy. Okay. Calculate the standard deviation. Well, SD, the standard deviation, this is all in your formula sheet, by the way, of your P. This is square root of P 1 minus P over N. Now, our P value here is, well, I'm just going to do it on a calculator, actually. Why? It's only 1 mark, so... Okay, just let me do this on calculator. Control N this. Alright, so we want square root of, our p-value is 0.7, 0.3 over 100 cupcakes. It's the square root of 21 over 100. Done. If the sample size was 600 instead of the 100, what changes, if any, could occur to the mean and the standard deviation of the sample? Okay, what should I know? That the expected value would not change because it's only dependent on the p-value and not the actual n value. But we're changing, so we can say mean will not change. Change. Yeah, it's 2 mark. It just says if the sample size, what changes would occur to the mean? Mean will change as it's independent to n. Next one. What about the standard deviation? Yes, it will change because it has the value of n here. And to really look at it like this, I'm just going to do a quick here. If I can take this and simplify it, so I can say that's P1 minus P. It's been times by 1 over root n. What's happening? So if n was 100, originally it was 100, and then it became 600, which is just pretty much a dilation by a factor of 1 over root 6. So we can say the standard deviation decreases by a factor of 1 over root 6. Yeah. The mean will not change, and the standard deviation decreases by a factor of 1 over 6. What would the curve mean? Yeah, that's that. That's that. I think that should give you that. Actually, yeah. Should give you the marks. What is the probability in a sample of 100 cupcakes that more than 66 and fewer than 72 of the cupcakes are vanilla flavored? So when we want to find this, the probability that more than, so 66 is not, and say let's say x is not than 72. But it says fewer than and more than, which can be written as what? Because it's binomial, so it would just be, if I draw the timeline here. Okay, so that's, yeah, so it'll be 67 equal x equals 71. And I'm going to use my calculator here where x is binomially distributed. Yeah, it's only 1 mark. I'm not going to write that rubbish. Yeah, it's just 1 mark. So that should equal to what? So go on my CAS, go menu, probability, distributions, binary CDF. Number of trials is 100 cupcakes. Probability of success is still 0.7. Is that right? Yes, 0.7. Your lower bound is 67. And your upper bound is 71. Enter. And we get to 3 decimal places. It's 0.402. I hope that's right. 0.042. Done. Done. During the afternoon shift, the bakery makes a batch of muffins. The number of muffins made per batch may be multiplied by the normal distribution x with a mean of 69 and a standard deviation of 7. There is a real number a such that q minus a must be less than... Okay. Doesn't it just 1 standard deviation? It's like the value of 1 standard deviation to like... And 60... Here, they're trying to trick you. Normally here, it will be 1 standard deviation from the mean if this was 0.68, not 0.64. One way I would do this question is calculate A, give your answer. So there was an actual exam question like this. I think it was in the, if I'm not mistaken, in the 2020 exam, or yeah, I think it was in the 2020 exam, if I'm not mistaken, that, you know, there's a quick way to do it, and this is how you do it. One of the best ways is, if I was drawing, think of it like this. If I'm drawing a normal distribution, say this is your mean, and we're saying something plus, so mean plus A, and mean minus A. So we're saying here, and we're saying that this point over here is 0.64. What we can do is, there's a formula that you should guys know, and you should put them in your formula sheet. It is pretty much this formula. It is the normal distribution formula, which is, I'm going to write it. Put this in your formula sheet, guys. This is so important. F of x is 1 over your standard deviation, square root of 2 pi, e negative half, x minus your mean over your standard deviation, all squared. This is a key formula, because what we're going to do here is going to solve A quicker. So what we can say is, we just want to find the integral from, well, our mean, we know what it is. It's 69. So we're just saying 69 minus A and 69 plus A of this function. Well, our standard deviation is 7, so it'll be 7, 2 pi e of half. Our x value we don't know, minus your mean value, which is still 69, over 7, all squared. Yeah, just doing that should give us your value of A. So yeah, I'm going to do that on my calculator. So there, my calculator. So it'll be the integral. So 69 minus A, 69 plus A, of 1 over 7 times square root of 2 pi times e negative half x minus 69 over 7, and we all square it, dx. What have I done here? What done? Oh my god, what have I done? Okay, I've not, and it's all equal. Should have wrote that. It's all equal to 0.64. So 0.64. Enter. Solve. Answer, comma A. And we get A is equal to 6 point. So it's 6.408 to 3 decimal places. Perfect. I hope that's right. Yeah. Done. A local delivery company claims that there is 90% probability that each delivery is made for, makes that the baker will arrive on time or earlier. Assume that the delivery is independent of the other delivery, so it's binomial distribution. Find the probability that on a day in which the delivery company makes 20 deliveries from the bakery, probability that more than 15 deliveries are, so we want X, more than 15 deliveries are on time or earlier. Just probability of X is greater or equal to 16. Yeah, and we just want to say X is binomially distributed, where 20 deliveries are made, and the probability of success is 0.9 of making it time or earlier, and we want more than 15, so we want that. Nice, so I'm just going to use my calculator here. Go on menu, probability, distributions, and go on binomial CDF again. And your number of trials here is 20. Your probability of success is 0.9. And your lower bound here is 16 to 20. Enter. You get 0. To 3 decimal places, so 0.957. That is your answer. Hope that's right. Question 5. I'm so tired. I just want to get this quickly done. Let f of x be this. State the amplitude. Very easy. Your amplitude is 2. Find the range. Your range is 1 minus 2 and 1 plus 2, which is -1, 2, 3. Give the general solution. Easy. I'm just going to do the calculator here. Control N this. Solve. Well, I'm going to define the function actually. So f of x 2 sine 3x plus 1. And we want to solve f of x equals 0, x, and it gives us 2 general solutions, so let's write those. X 12n minus 1 pi all over 18, and x is 12n plus 7 pi all over 18, where n is an element of all integers. Calculate the sum of the solutions from this domain. Okay, very easy. So I'm just going to say, take this here, and we want to say from negative 10 pi, 3 must be less or equal to from negative 5 pi, negative pi on 3. And here it is, and I'm going to take all of these. I'm going to sum them all together. I think they should all sum up, because they have negatives. No, it doesn't. It just multiplies them. Okay, so what I'm going to do is I'm going to take this first here. I'm going to add it. I'm going to take this one over here. I'm going to add it. I'm going to take this one over here. And add it. And I'll take this one over here. And add it. Negative 10 pi. So, sum negative 10 pi. Last page. Okay. Let the definite integral g of a be from 0a of f of x dx, where this is given by this. Okay, so let's define g of a. So negative 2 cos 3a minus 1 over 3. And find the maximum value of g, and find the maximum value of g and the value of a for which this occurs. So 2 marks. Okay, what I'm going to do is I should go on menu, calculus, go on maximum first, because we want to find the maximum value of g of a, comma, the a can be from only 0 to pi on 2. Enter. So our a value for maximum is pi on 3. So our max value is, if I sub that into g, and if I sub that there, 4 over 3. Yeah, that should give us that. Find the minimum value of g and the value of which occurs. So same thing, take this here, change that to min. So min value occurs at a equals 0, and min should equal to what? So it's g of 0, which is 0. Done. Find the value of a such that 1 over a times g of a, this, give your answer correct to 3 times 1 mark. Okay, so I think I'll do this on calculator. Alright, so 1 over a times g of a equals 1 over pi over 2 minus a times the integral of a pi over 2 f of x minus 1 dx. And we want to solve answer a, comma a, given that a can only be between 0 to pi on 2. Control enter, and we get 3 values. Okay. I know a can equal to 0, but we want to find... It says find the value, not values. So, okay. Let's really understand what this means. 1 over a times g of a. Aha! This is what they've done. If you really look at this, this is here is what we're trying to find is the general solution of g of a. I mean, just have a look at this. Look at the terminals. So normally it's 1 over b minus a of a to b. So a to b, b minus, yeah. So can you see how your b value here is pretty much, your b value here is pi over 2. And yeah, so this is your average value. So pretty much here, what it's saying, it's like it's calculating the average value of g of a from, a to pi over 2. And that would pretty much bring g of a just times by 1 over a, like a dilation. And that's what our value of a is. Ah, okay. Okay, so which one of these values? So it's one of these values. So what can we do? Well, I'm just going to graph it. Okay, wait. Find the values of this. Okay. If I graph g of a, in this case, so let's say g of a, I don't even want to put a slider for a anyway. Is that right? Wow, this is confusing. Find the value of a such that this... Let's put a is that. Okay. And we know a can only be between 0 to pi on 2. Okay, and we get this. Okay, it's quite useless, I'm not going to lie. What the hell is this? If I say... So we said g of a. Okay. Just copy that. Control N everything. And say this, I'm going to define that as that. And I'm going to define x back to what it was. Which was 2 sine 3x plus 1. Okay, plus 1, yeah. Okay, so we got these two. And we already knew two values already were. But I'm here confused because, like, what? Well, I know a couldn't equal to 0. It was one of those two values. But which one would it be? Well, I think it would only be the second one, because if I draw this whole function, like, imagine 1 over g times a. What we're saying is, if I drew here, 1 over a times g of a. Imagine drawing this function over here. And wow, this is quite... Yeah, why is this? Let me just draw the other one, maybe 1 over pi over 2 minus a times a pi over 2 over x minus 1 dx. Enter. Okay. Take this over here. Find the value of this. Okay. Okay, I think I found it, how to do this. Yes, I think I found how to do it. If I just rub this and say g of a, let's look at the... Well, g of a is... a g of x. Let's actually just look at g of x first. That's why I'm not fair. So let's look at g of x right now and say that we're going from... So this is g of x, and let's say this was in terms of a. Like, x was a. That's what we're saying. And we want our a value from 0 to pi on 2. So if I was drawing, let's say, menu, graph, relation, x equals pi on 2, which we get this. So we only want this. And we're saying we want to find where we're getting the average value from this to this. So the average value should be here. Like, it should be around this part here. Like a line. Yeah. But our max value, like if we look here, what's our max value? So our actual average value cannot be greater than 1.33. So it would have been the middle one, because the other one was like 1.6 if I'm not mistaken. So using that to my advantage, I think... yeah, I'm just going to resolve that again. I don't know why I deleted it, but let's resolve it and get those two. I can't, yeah. So, okay, it must be the middle, yeah, 1.3. I have to re-delete the whole thing because it's already defined as a variable and I don't know how to delete it. So it cannot be, yeah. So if I can just say that f of x, this is quite annoying, 2 sine of 3x plus 1 g of a is negative 2 cos 3a minus 1 over 3. Okay, and we're saying solve 1 over a times g of a equals 1 over pi on 2 minus a times the integral of a pi over 2 f of x minus 1 dx. Okay, so we get this comma a given that a must be kind of between 0 pi on 2. Here we go. So it would only be, look, the max we got was 1.33. This here is above the max, so it can only probably be this one. Yeah, I think that's 100%. It should only be this one. It says only find the value. So yeah, let's write that down. A is equal to 0.144. Yep, hope that's right. Yeah, I'm not too sure. Yeah. That's a pain, but yeah, let h of a be this, where k is greater than 0 and a must be this. Give the values of k is greater than 0. Given that h of a 4/3 for some value of a. It's only 1 mark. Look, these are probably hard questions. So for this one, what I would do is think of it like this. We know we want h of a to be equal to 4 on 3. So if we like equate this, give the values of k greater than 0 for some value of a, Okay. I'm just gonna, let me just graph this on my CAS. Like these questions, like the last questions tend to be easier when you graph them, because they tend to be those, like using algebra is quite useless for the last question. So yeah, just make sure you use the graphing technique to really look at the sequence. K times pi over 3 minus 1 dx. Okay, so we have this. Perfect. And yep. So let me just take this out. And we also want to create another one, 4/3. Perfect. So this line, we want the blue one to be equal to the red line. Okay, and we know that k can only be greater than 0, so let's be safe and say that this is 0, and let's say this is 10. Or let's say, no, 8 now. And our a values can only be 0 to pi over 2. Okay, pi over 2. Perfect and nice. Okay, so let's start with k equals 1. Wait, okay. Let's start with k equals 1. Make it easier. K equals 1. Let's put that 5 actually, yeah. Okay, nice. Let's say we start with k equals 1. And what can we see? Well, when k equals 1, our a value, so it says give the values of k, given that this, okay. So here, if we move this up or down, it really doesn't reach. Our a values doesn't actually have any like values here. It doesn't even reach. So if we increase k equals 2, or half, still doesn't reach. When k is 2, it reaches. Yeah, so it reaches. Okay, that's good. So yeah, we can see like it touches at some point. Yeah, so it does touch at some point. What about when k is equal to 2.5? Yeah, so it still doesn't reach. What about k equals 3? K equals 3.5. Or k equals 4. Okay. So what can we see? Well, k takes only even integers. I mean, we said 2, 4. Let's try 6 to be safe. 6. Yeah, so even 6, you can see that it touches it. So we can see that k can only go by even integers. So let's just write that down. We can say that k is 2n, where n is an element of all integers in the positive. Remember, we're only taking values of k that are greater than 0, and we're taking So okay, that could be useful. That's good. So we at least give the values of k greater than 0, given that h of a 4 on 3 for some value of a. For some value of a. So we need an a value too. Well, what value does it reach when we go on top? Like 1.1, which is what, like half of pi. Let's say pi on 6. Oh no, pi on 3 actually. Pi on 3. pi on 3, because we know that from the other one, pi on 3 was our a value that gave us the maximum value of g. So if we were down there, so now they intersect. So pi on 3 is pretty much the a value that gives the maximum, or like the value of 4 over 3, like it intersects it. So let's write that. So for some value of a, let's say a is pi on 3 in this case. So when a is pi on 3, k equals 2n, where n is an element of all integers. I hope that's right. I don't think it is. It's a hard question, I'm not lying. So let's try a. Let's try a now. 9. Oh no, so well, if we put 9, because it's odd, it doesn't. What about 10? So, okay, when a is that pi on 3, when k is 2n, like even integers, yes, it always intersects it. So I think that's that. I think, yeah, I'm quite tired, I'm not gonna lie, so I hope that's right. If it's not, yeah. Yeah, because the solutions haven't been posted by VCA, so these are my suggested solutions. I hope most of them are right. Maybe I would have got like maybe 2, 3 wrong, but yeah, it shouldn't be a problem. Yeah, guys, I hope you enjoyed this video. Yeah, I'm quite tired, and yeah, I hope you learned something from this video. Please, guys, if you want more videos like this, please subscribe to my channel. It kind of gives me the motivation to do more of these videos. Please comment down below, if you have any questions that you're not unsure of, or tell me what videos you want next, or yeah. I hope you guys enjoyed this video, and yeah, if you guys want private tutoring, yeah, it's always my email's in the link in the description. I hope you guys have a good day and take care of yourself. Bye bye.